Welcome to RCR Wireless News. I'm Martha DeGrasse, and I'm here with Kashif Hussain. He is go-to-market leader for RF test at Viavi Solutions. Kashif, thanks for being here today.
Thank you, Martha.
Our topic today is fiber and mobile networks, and we hear a great deal about the advantages of fiber and mobile network architectures, less about some of the disadvantages and challenges. So if we could, I'd like to start off by hearing from you a little bit about some of the advantages and disadvantages of fiber and mobile networks.
Yeah, that's an excellent question. I mean, if you recall, in the past, we used to have coaxial cable going all the way to the top of the tower to the antenna. The problem with the coax cable is multiple problems, actually, if you look at it. One is coax cable has a much significant loss. What does that mean? Which means that I'm going to lose at least 3 to 4 dB, depending on, the type of the cable, the connector, and how the whole site was built. Now, if I can replace that with something which is much more efficient, in which there is much less loss, then that would be great, right? So that was the idea. However, how do I replace that? My radio, after my radio, when I actually take the RF spectrum and I transmit the signal on the RF, that was the only medium. So the one method was moving the radio to the top of the tower. There are a couple of challenges with that. In the past, radio technology was not there, where you can have long MTBF, which is mean time before failures for the radios. Also, there were other challenges as well. Now, let's look at from the radio advancement. Since the radio technology has improved significantly, now MTBFs have improved, and the technology is such where I can hang these radios on the top of the tower. So how do I connect these radios to the base of the tower? So the medium that is chosen is fiber. So now I have a fiber which goes from the top of the tower, basically from the radio, to the digital unit, also known as baseband unit, right? So basically BBU and the radios are sometimes called RRUs, remote radio units, or remote radio heads. However, people feel comfortable, and depending on the vendor, right? Now, if you look at that, there has to be some sort of a communication that has to go between the radio and the base of the tower. So there are multiple standard interfaces defined in the industry. One is CPRI, which is Common Public Radio Interface, and the other one is the OPSI. So there were 5 companies which joined this group and created the CPRI requirements. Loosely, it is a standard, but it is there is still a lot of, I would say, proprietary information that is sent. Basically, how do you take the RF information and map it on the CPRI is actually kind of proprietary, and how they do the mapping is very different. The idea is similar, like in any digital communication, where you take the information, you convert it into, basically do digital modulation. I actually convert it into packets and then ship those packets on the fiber physical interface down to the BBU, where the BBU can open those packets and understand what was sent. And basically you are sending the RF information in a digital format. So what was the advantage of it? The basic advantage is that now, I'm improving my RF link significantly. 3 to 4 dB is quite significant. If you take in RF terms, half power is 3 dB. So if I'm getting 3 dB more, I'm significantly increasing my coverage area in terms of capacity. In an environment where you have a reuse ratio of 1, and depending on you are using the WCDMA or OFDMA technology, then in that case, basically you're gaining capacity too, because you're improving the noise floor. So you can see the advantages. So I'm going to increase my signal around the cell site, especially at the edges as well. I got basically a better signal to noise ratio, better capacity, what have you, right? All these benefits, they are adding together. Now, one thing that people don't consider, but if you think about it this way, the huge size of the cables. Now, if I remove that size of the cable, I'm significantly also reducing the tower loading capacity. Because now I have the lighter fiber cable, although I do provide the power. So you can be using a hybrid cable, which has fiber and a power line going together, right, up all the way up to the tower, which is still significantly lighter, and you're providing service to multiple sectors, meaning you have 3 radios at least for one carrier, depending on the vendor and what have you, right? So instead of 6 cables, you're shipping, you are moving 1 cable from the base of the tower to the top of the tower. So that also helps with the leasing advantage. But that was not the primary reason the operators actually introduced fiber to the top of the tower. The primary reason was actually the better RF performance using a fiber cable. So those are considered as like the key advantages of putting fiber out there. Now let's look at the disadvantage. So before, the radio was at the base of the tower. So one more thing that I missed, which is the PIM. So when you have basically a coax cable out there, there are a lot of passive components. And when you inject two different carriers, meaning two channels, there is a potential of third order or fifth order modulation. And if that signal which is generated is significant enough and it can land in another band or another carrier, it can cause a passive intermodulation issue. Passive intermodulation issue is caused by passive components in basically the cable to the antenna path. It can be caused by any of that, like you have splitters, you have diplexers, you have cable itself, you have bends in the cable, the connectors are not done right, or corrosion in the cable, or even the metallic structure outside. So when all this stuff that is there going in the coax cable, if you look at the cable and antenna system, then there is a lot more potential of PIM. Now, using fiber to the antenna, you also minimize the PIM problem as well. Now the problem, now let's talk about the challenges. The biggest challenge, if you look at it, is how do I actually troubleshoot my RF spectrum from the base of the tower when my radio is at the top? So for that, people were about like few years ago, people are looking for a solution, and Viavi was working with the industry leaders when it comes to service providers and network equipment manufacturers. And we actually were the first ones to offer a RF over CPRI solution. So basically, taking the CPRI packets, opening it up, and reading the RF information in it, and mapping it in such a way that you can see what kind of interference problems we are seeing in that. So basically, you have resolved the RF issues that were out there, right? And you couldn't do the analysis unless you go all the way to the top of the tower. So now connecting a base station analyzer from the base of the tower where your BBU is sitting, you can actually look at the CPRI signal and you can actually do the same analysis. We actually did not just stop at CPRI. Like I said, there was another interface, which was the OPSI interface. So there are some companies, some network equipment manufacturers who implemented the OPSI interface as well. Some operators in US have installed OPSI, but to a much lesser extent. Similarly, in EMEA, I also see OPSI being deployed, and also in Asia. So we actually also analyze similarly the RF over OPSI analysis too. We can actually open up the OPSI packets and provide the same kind of information that we do. And we also cover pretty much all the different manufacturers or the vendors of the equipment, meaning the Huawei's of the world, the ZTEs or Samsung or Ericsson or Nokia. So we actually work with all of them. So basically, RF over CPRI can give you the same RF information for which, now the access is at the top of the tower, and you can get that information from the base.
So as far as CPRI versus OPSI, more vendors support CPRI, right? You said 5 vendors support CPRI?
Absolutely. Actually, pretty much everybody now is getting on the CPRI bandwagon, I would say. There are still some, I would say, outliers, and I would say significant portion of the networks that are deployed with fiber to the antenna have the CPRI interface being used, the CPRI technology used between the BBU and the RRU or RRH, whatever, however you want to call it. Very few networks are out there. In fact, with the purchase of Alcatel-Lucent by Nokia, Alcatel-Lucent primarily used, the CPRI interface. Nokia at some point implemented the OPSI interface, but I'm seeing that there is also some movement towards the CPRI. So CPRI is getting a lot more traction, and I see it as a technology that is getting deployed wider. Also, if you look at option 10, you have a much higher throughput offering on the CPRI interface, almost 24.3 or something to that effect. You can see, throughput that you can, because the throughput is important, because the amount of data that you can send to the multiple radios. And as we go towards 5G or 4.5G with higher modulation rates and what have you, then in that case, you will need an interface which is much faster.
So you feel that CPRI is in most ways superior?
Compared to OPSI, at this time, yes, it is, definitely.
Okay. Okay, great. Are there any other challenges you see with fiber? And let's not just focus on towers, but also fiber in CRAN architecture, small cell architectures, those types of architectures.
So in the beginning, the bigger problems that we saw with fiber, that the technicians and the cell tower crew was not very much familiar how fibers, I mean, basically are connected and whatnot, right? And you can see then in that case, I mean, I will start from the very beginning, the challenges, right? So the first challenge I would talk about is how do you manage, I mean, fiber connectors and all that stuff. People thought that, you know, if there is a cover on the fiber, it must be clean, everything is fine. But a micron of dirt can significantly impact your signal quality. And that's why cleaning was necessary. So a lot of training had to happen for these technicians who are used to working with these big coax cables. So that was one challenge, and for that, a lot of inspect before you connect kind of methodologies were introduced, and things like that are being practiced in the industry. Where now you can see that people are getting trained. So that was one thing. Now going to the CRAN scenario, right? I mean, the fundamental of CRAN. Why do you want to go to CRAN? I mean, the biggest advantage is the LTE advanced features. For example, the COMP features, which is coordinated multi-point, right? Basically, in which at the cell edge, you can cancel the interference effects and manage data throughput through multiple sectors or multiple sites. In fact, truly implementing the heterogeneous networks, meaning you can have data provided to a mobile from a macro cell and a small cell and what have you, a combination of it. So you can implement that through these heterogeneous networks, and CRAN plays a vital role because now the BBUs are moved into a baseband hotel, and the coordination is much faster. And now, instead of using just the X2 interface between the radios, you are actually working within the same, I mean, I would say the cell site hut or whatever the hotel, and your coordination is much faster, and you can truly use the LTE advanced capabilities. So that was one of the reasons that CRAN is getting deployed much faster. Again, the challenge with that would be you'll have to manage your fiber interface. You'll have to ensure the fiber links are clean and what have you. You'll have to do the proper testing. You'll have to, I mean, the provisioning is, there are certain steps that are required for provisioning as well. Ensure that all the wavelengths and everything's are checked, what have you. I mean, going all the way back to the, I would say the MITSO, right, in that case. So it offers certain advantages, but also you have to be careful. I mean, that everything has to be tested properly and what have you.
Okay, great. And where do you see the technicians gaining all the training that they need in order to work more effectively with fiber?
There are multiple venues. I mean, different companies offer, I mean, training classes. There are a lot of videos. I mean, as you look at in this industry, right? So there are certification requirements for this. I mean, as well as there are people. Usually, the technicians learn from, I would say, their peers in most cases and what have you. But certain, for example, in a DAS scenario where fiber, especially in the active DAS, where there is a lot of fiber work needs to be done. Remember, what are the fundamental testing for fiber required? Let's start from the beginning. First, inspection of the connectors and cables and what have you. Ensuring that your power losses are within the spec, meaning if you have designed certain lengths for certain losses, you have to measure those. Okay, in cases where you don't meet that, you can run a VFL, which is the visual fault locator, to identify if there was a macro bend or there was a problem with the cable itself. If you are meeting all those things, then you also perform the OTDR test, which actually is very much similar to, like in the coax world, you have the distance to fault and insertion loss and what have you, and you identify the different places where it can be, where you can have a problem and things like that. So from a technician point of view, they truly need to perform all these additional tests on the fiber. So that, again, if you compare this to the coax world, very similar. The only difference is now your interface has changed from a much heavy coax cable to a much lighter fiber world, in which you will have to again perform the similar type of testing, although the tools will be different. Now you'll be using fiber microscope, or you will be using some sort of a power check device, which can help you. Introducing a light source and measuring the power on the other end, things like that, and an OTDR test or whatnot. So from technician perspective, they need to ensure that all these tests are done. There are certifications available. For example, there are certain companies which offer certification for DAS testing, in which all these things are actually, technicians are trained on all these key things in that regard.
Okay, great. And do you offer any certifications on your equipment?
Yes, we definitely do. We offer certification on our cable and antenna analyzer, both for fiber as well as for coax. We also have training courses for base station analyzer, for RF over CPRI and RF over offsite training. We definitely do all those things.
Okay, great. All right, Kashif Hussain, go-to-market leader for RF test at Viavi Solutions. Thank you so much for your time today.
Thank you, Martha.